Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find if array can be sorted. Leetcode 3011. In this problem, we are given a zero index array of positive integer nums and we have to determine if we can sort this array or not. We will return true if it can be sorted, otherwise we will return false. In one operation, we can swap two adjacent elements if they have same number of set bits. We are allowed to perform this operation any number of times, including 0 times. Then in example 1, for the given input array, our output will be true because this array can be sorted. The number of set bits in 8, 4 and 2 is 1 because binary representation of 8 is 100, binary representation of 4 is 100 and binary representation of 2 is 10. And number of bits set in 30 and 15 is 4 because binary representation of 30 is 11110 and binary representation of 15 is 1111. Now because 8 and 4 have same number of set bits and 8 is more than 4, in one operation we can actually swap them so that we can get the elements in the ascending order. So now the array becomes 4, 8, 2, 30 and 15. Then again 2 and 8 have same number of set bits and 8 is more than 2. So in one operation we can swap them as well. So now our array becomes 4 to 8, 30 and 15. Now 8 and 30 don't have same number of set bits, so we cannot swap them, but they are already in the sorted order because 8 is less than 30. Then 30 and 15 have same number of set bits, so we can swap them as well. So now our array becomes 4, 2, 8, 15 and 30. And finally because 4 and 2 have same number of set bits, we can swap them as well. So now our array becomes 2, 4, 8, 15, 30 and this array is actually sorted in the ascending order. So that's why we will return true as our answer. Similarly in example 2, we will return true as well because array is already sorted and we performed 0 operations to sort this array. And finally in the last example, for the given array, we will return false because this array cannot be sorted. The number of bits set in 3 is 2 and number of bits set in 16, 8, 4 and 2 is 1 each. So because 16, 8, 4 and 2 have same number of set bits, we can perform multiple operations and sort this part of the array. So it will become 2, 4, 6 and 8 and this will come as 3. And because 3 and 2 have different number of set bits, we cannot swap them and because of this array will not be sorted and hence we will return false as our answer. Now in terms of solution, one of the naive approach can be what we did in the example. If you noticed, we were performing bubble sort. So in step 1, we start at the beginning of the array and compare each element with the element next to it. And if they have the same number of set bits and they are out of order, that is larger value comes before smaller value, then we will swap them. Like we bubbled out 8 from numbers 8, 4 and 2. And now the question is, how can we determine number of set bits? We can do it with our own implementation. For example, I have already covered the problem on this channel called number of 1 bits, where we find out number of set bits in an integer. If you are interested in it, please check it out. Or we can use a built-in library. For instance, integer.bitCount in Java. For this problem, I don't want to reinvent the wheel, so I will use inbuilt library and continue scanning from left to right and perform the swaps where needed. And finally, we can check if the array is sorted or not. And how can we do that? We can again loop on the array and check if the adjacent elements are in ascending order from beginning to end. Or we can use inbuilt sort library on the copy of the array and check if the sorted copy and the array we just sorted are same or not. If they are same, then we will return true. Otherwise, we will return false. Now let's jump into the code part. First, let's get the length of the array so that we can loop on this array. Then we will write the typical bubble sort code with two nested loops. The outer loop runs from the start to the end of the array, and the inner loop also runs from the start of the array to the second last element in the array. Now for each adjacent elements, we check if they have the same number of set bits using integer.bitCount and the elements on the left is greater than element on the right. If yes, then we will swap them. And once we are done with the bubble sort, we can create the copy of the array. Let's call it sorted nums and sort this copied array using built-in sorting function. And finally, we can compare sorted numbers to modified numbers array. And for that, in Java, we can use arrays.equals method. And this method will return true if the copy and the modified nums array are same. Otherwise, it will return false. Now let's submit this code. Cool. Even though it was very inefficient code, it was still accepted. In terms of time complexity, it will be O of n square into log k, where n is number of elements in the nums array and k is maximum element in the array. And the reason for this is we are running this nested loop, and because of this the time complexity is O of n square. And then for each number we are getting the bit count, which takes log of number time, and the maximum time it will take is for the largest number. So because of this, in the worst case, the time complexity will be O of n square log k. And in terms of space complexity, it will be O of n because we are creating this sorted copy. And now the question is, can we do better? And the answer is yes. Now if you observe the array closely, there is some sort of a partition in the array which is created by common set bits. For example, in this array, there is a partition between numbers 8, 4, 2 and 30 and 15 because number of set bits in these numbers are 1 and number of set bits in 30 and 15 are 4. And we can perform swap operation within those partitions to make the array sorted in the bubble sort way, resulting in time complexity of O of n square. So how about we chunk or group these elements based on the set bit count, and instead of sorting these elements in the bubble sort way, we can actually sort the chunks using some efficient algorithm like quick sort or merge sort, and then the time complexity reduces from O of n square to O of n log n. For instance, here we got the chunk 842 with 1 set bit and chunk 30 and 15 with 4 set bits. And once we sort these chunks, we will get 248 for first chunk and 15 and 30 for second chunk. And finally, we merge or chain these sorted chunks and check if the array is sorted or not, just like we did in the previous approach. And before we jump into even more optimal solution, yes, there is even more optimal approach. Note that for grouping the elements by set bit count, do not use hash map because using the hash map would lead to losing of order. And when we are merging the partitions, partition order is important. So instead of using a hash map, use a simple list or some other data structure to chunk or group these elements properly. Now coming to the most optimal approach, we know that arrays have partitions based on set bit counts. So far, we have been sorting the arrays to check if array can be sorted or not. This is why the time complexity is O of n log n or higher. But do we really need to sort the entire array? And to answer that, let's look at the partitions a bit closely. If we look at this array, can this array be sorted? And the answer is of course yes. We have done it today so many times. But now consider this array. Can this array be sorted? If you observe closely, this array also has two partitions, one with numbers 16, 4 and 2 with 1 set bit and numbers 30 and 15 with 4 set bits. So if you attempt to sort this partition, this will become 2, 4 and 16 and this partition will become 15 and 30. But if we combine them, this whole array is not sorted. Why? Because the maximum element in the first partition, that is 16, is greater than some elements in the next partition. So this array cannot be sorted. So to solve this problem more efficiently, all we need to do is track two maximums. One is the maximum value in the current group. For example, it will be 30 in this case, and the maximum value in the previous group. For example, it was 16. Suppose we are tracking now this group. So if the element in the current group is less than the highest number in the previous group, then we will return false, because if we combine these sorted partitions, the whole combined array will not be sorted because numbers cannot jump between the partitions. For example, 16 cannot go after 15 because they are in different partitions. Otherwise, if all the elements in the current group are greater than or equal to the previous group's maximum, then these two groups can be sorted and combined. So now we will repeat this process for the next group, and for that we will update the previous group's maximum with the value from current group's maximum. For example, if we had the partition after 15, then the previous group maximum for the next partition would have been 30. so that we can start the comparison with the next group. And we will continue this process until whole of array is done. So this optimized approach reduces the time complexity to O of n, because now we are just going through this nums array and finding the maximum value in the current group and setting it as previous maximum value for the next group. So now let's jump into the code part. First, let's remove this old code. Now we can define the variable previous group maximum to keep track of the highest value in the previous group. Initially, we can set it to 0. Let's also define max to keep track of the highest value in the current group. Initially, we can set it to the first element of the array, indicating the first group in the array. Now we can start iterating on the array from the second element. Now first thing we will do is check if there is change in partition. And how can we do that? We can check if number of set bits in the maximum element and current element are different. If yes, then this indicates change of group. So we will set previous group maximum to current group's maximum value. Also, if current number is more than current group's maximum, then we will update maximum to this number. And at any point, if current number is less than previous group's maximum, then we will return false, because current group cannot be sorted relative to the previous group. And finally, if we are here, that means we couldn't find any violations, so we will return true, indicating this array can be sorted according to the given constraints. Now let's submit this code. Cool, this time runtime improves and beats 100% of Java submissions. And in terms of time complexity, it will be O of n into log k, where n is the number of elements and k is the maximum value in the array, because we are going through n elements in the loop, and then for each element we are counting the number of bits set in it, which takes log of number time, and this value will be maximum for the maximum value in the array. So because of this, the time complexity is O of n into log k, and in terms of space complexity, it will be O of 1, because we are using some variables here and there. So that's all for this video. We went from O of n squared to O of n log n to O of n. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.